So that should go until the light turns on, right? Whoa. Did that just blow up?
Hey Internet, welcome to my video. Here's the circuit I was trying to wire, and here's the waveform it produces across the load at full brightness. We'll look at that in detail in a minute, but first, we're going to look at this potentiometer blow up in slow motion. This was recorded with my Galaxy S21 Ultra. The slow motion setting records at 240 frames per second and plays back at 30 frames per second. I killed 2 of these potentiometers while testing the circuit out, and 4 or 5 of these capacitors as well. The capacitors blow up so fast that I had to use the ultra high speed setting on my phone. It fires a burst shot of about a half a second long at 480 frames per second. To get a proper recording of this, I had to time the shot perfectly, and I couldn't do that here. So I used a similar capacitor at home, and I plugged it directly into the wall. This isn't safe, and you definitely shouldn't do it. Here it is at 16 times slower than real time. In ultra high speed mode, no sound is recorded. Despite how dark it looks in this clip, all the lights in the room are on and pointed directly at the experiment. When recording at high frame rate, the exposure time of each frame is reduced. The camera has less time to absorb light per frame, and so it appears darker. Here's the initial 6 frames of the explosion slowed down way more. And here's what was left after the explosion. After getting the circuit to work, I recorded the light bulb in ultra slow motion as well. Because this is a half-wave rectifier, the bulb will pulsate 60 times per second. At this low brightness level, the brightness increases for 4 frames, while it decreases for roughly 12 frames. This closely resembles the waveform below. In this clip, I scale the brightness of the bulb up from low to high. I can't animate it, but here are some pictures of what the waveform should look like roughly at the different stages of brightness. Next was the full wave AC dimming circuit. The full output waveform looks like this, and the low output waveform looks like this. Here's what it looks like as I scale the brightness up. Because the light bulb will receive both the positive and negative halves of the wave, the pulse rate will be 120 Hz instead of 60 like in the half-wave rectifier. This can be seen directly if we compare the 2 clips side by side. If you look closely, you can see that the bulb on the right pulsates twice as fast as the one on the left. That's all for now. I hope you enjoyed the video. Thanks for watching.